So what I'll show is some basic use of HOOPS Exchange as you would use it out of the box. And then I'll introduce a couple of tools in that extra header that I mentioned that I think that you'll be able to use pretty much immediately. And if you're writing code or adapting code, it will reduce the amount of code that you need to write and hopefully make things a little bit more maintainable and readable. So that's the goal here today. It's just to introduce some basics and give you some tools to help things along. Okay, so if you had the package or any package with that header in the include folder, we're just going to start in the samples and we'll open Exchange, the Exchange solution. You should be familiar with this. If you're not, this is just a sample solution that ships with Exchange. It includes a bunch of individual projects, some of varying complexity. Some are extremely simple and some are a little bit more in depth. We're going to start with the most simple of all possible samples called import export. So in order to get that working, if you're opening this for the first time, always have to change this mixed platforms to x64, and I'll stick with debug. We're going to go to import export, and we'll set this as the startup project. And we'll take a quick look at this code. So import export is very simple. It initializes HOOPS. It includes the header, initializes HOOPS with a license file that is all handled within this HOOPS Exchange loader. And the heart of it is setting up an import object and export object, and then this call to convert. So just to make sure that life is good, we'll compile this, make sure we don't have any errors or warnings. Seems like it's ready to run. So I'm going to grab a data file. So we'll go to the data folder within samples. I like to use the micro engine. So this is a CATIA file. I'm going to grab the top level assembly. I'm going to hold shift and right click, copy the path of this file. And I'm going to edit the project properties. And in the debugging tab for command line options, I am going to paste that path as input, and I'm going to paste it again as output, but I'm going to add the extension .prc. So what this is going to do is load the cat product, and it'll write it as a PRC file. So nothing too special here. I hit Control F5 to run. It's loading the file. It's populating HOOPS Exchange, and it wrote it as a PRC file. And to verify that, when I look at this folder now, I see that .prc file. So that's wonderful. So, but what we're really here to do is something a little bit more complicated and interesting. So let's take this .convert out of here. And really what happens when you call .convert is it's doing the read and the write. So we can say import simport, and we can follow that by HOOPS Exchange loader export and pass in the s export struct. So essentially, we're doing the same thing here. We're loading the file and then we're exporting it. But what that gives us the ability to do here is put some code in between. So the HOOPS Exchange loader has a member variable called m_ps model file. So after the import occurs, we have a handle to the model file that was loaded. This object is of type A3d ASM model file star. If you are unfamiliar with HOOPS Exchange, or even if you are familiar with HOOPS Exchange, it may not immediately occur to you that A3d ASM model file is actually a type def to void. So this is an opaque handle, A3d ASM model file star. And in fact, there are a lot of objects within HOOPS Exchange that are the void type. They're just abstract handles into the data model. So you really can't do a whole lot with this object. In order to use it, you need to get the data from the API. And the way that you do that is through a function call called A3d ASM model file get. And I can pass in the model file, and I have to pass in an A3d ASM model file data struct. So this is a data struct. Notice it has all the same identifiers, but it also has the word data on it. And when I see the word data as a postfix to some identifier, I think immediately that that's a struct. So we'll just say model file data here. And I will declare this guy. I know that it is A3D ASM model file data. And this is by address. So this function call will actually populate the data structure. And it returns a status. So let's just make sure that that's correct. So make sure that the API was successful. So just like this, I know that I'm going to run into a problem because there's a special field within model file data called m_us struct size. This has to be initialized because when we pass this struct into the Exchange API, it needs to verify that the memory that we're passing in is of the correct size so we don't stomp on memory. The way that that's done is a macro that we use throughout Exchange, this initialize data. Oops. I'm going to do that a number of times, so get used to that. This initialized, oops, see, what did I tell you? This initialize data call is just a macro in the header. And really all it does is a mem set. It sets everything in the struct and it initializes that m_us data, the m_us struct size to the correct size of the struct. So now this function should work. And if it is successful, I'll have data. So I'll be able to access model file data dot m_, for example, m_b unit from CAD. That tells me whether or not it read a unit at that highest level. So I'm going to pause here just for a second and see if, maybe give me a little bit of feedback on the pace here. Too fast, too slow, speed up, slow down. There are little icons. If everything is good, all right, I got one go faster. It seems like you're the lone person out there. So I think I'm gonna keep going at this pace. If anyone needs me to slow down, let me know. Jump in, let me know. Okay, cool. All right. So what do we have here now? Through this API call, I populated this struct and I'm ready to use it. I'll say use the data here. And if I'm done with the data, I need to free it. And the way that that's done is through a repeated call to this A3D ASM model file get. But instead of passing in the opaque handle, I pass in a null pointer. That signifies to the API that I want to free up this data. I'm done using it. So what does using the data look like? So I might iterate over the product occurrences. And when I say product occurrence, think of assembly node. So I'm simplifying things. There are some things I'm going to gloss over for the sake of those of you who are not entirely familiar with Exchange. So if you're a stickler and you catch something that I'm not saying correct, there may be a reason for that. So I'll say a loop here over the product occurrences. So if IDX is less than model file data dot m_ui product occurrence size IDX, and I can say model file data dot m_p IDX. So here I have a product occurrence. And again, this is an opaque pointer. So just for clarification, so I'm a stickler. I love the auto keyword. Ever since I learned about it, I started using it. But just to be clear, this is A3D ASM product occurrence. A3D ASM product occurrence star. Yeah, so that's what object type this is in product occurrence. Again, opaque pointer, see type def void. So this is just an opaque pointer. And I would do the same thing here. If I actually want to use the product occurrence, I'd have to declare A3D ASM product occurrence data. I'd have to initialize it and call get on it. Then I'd use that data and then I'd free that data. So you see that pattern repeatedly in your use of HOOPS Exchange. So one might think, how can we make that easier? Well, one way would be to create a struct. So let's do that. A3D ASM model file data. We'll call it a wrapper. And here we will create a constructor that takes that opaque pointer and we'll just handle the management of the data and the initialization, the get, and the free. So this may be something that you've written, or it may be something that you've lifted out of code that you've already found. Sorry, let me just wrap this up here. So we're going to initialize it, and we are going to say if model file, then we'll call A3D ASM model file get, passing in the model file and a pointer to the struct that we just declared. So that's good. Now we can use that data easily, and if we create a destructor, we can just automatically free this guy up. And we don't have to think about it so much. So now we have a struct that when we declare it, it initializes and it gets, and when we free it, when it pops off the stack, it'll automatically free up that data. So this is a nice, easy way to do that and make access to that data even maybe a little simpler. I like to add an overload to the arrow operator. So this makes life a little easier. So with this struct written, let's go back to our code down here where we're using it. And instead of all this stuff here, I think we can comment that out. And instead I can call A3D ASM model file data wrapper D and pass in model file. And now through D, I can access all the member variables. And when it goes out of scope, it'll free itself up. So I just took, yes.
Sorry, this is Nicholas from Volume Graphics.
Hello.
I have a question right there.
Mm-hmm.
Because initially you were asking for the return value of this A3D ASM model file get.
Yes.
But I think in the struct above, you don't really consider this anymore. And
that is true.
I wanted to know, like, when is it safe to just omit the return code here? Because in my code, I have a lot of code that asks for this A3D success.
Mm-hmm.
And yeah.
I will share with you a tool that will help with that in just a moment.
Okay.
But I will point out that because this is in the constructor, it does complicate things a little bit, but there's a way around it. It's maybe a little more difficult to deal with because it is in the constructor, but there are ways that it can be dealt with. If you're okay with using exceptions, I'll show you a way that you can throw exceptions if this fails. So you can put try catch blocks around your use of this structure.
I see.
But my point of showing this is to actually introduce you to the header that is included in the distribution if you downloaded it. So we're going to go ahead now, and I'm just jumping back to the code just to remind you that we eliminated a bunch of code here and created this struct now that manages the mechanics of this. So rather than having to write this struct for every data type, I would encourage you to use the ones that we have written for you. And the way to do that is to add the Exchange Toolkit to your project. And in order to do that, I'm going to start by, I have to add a couple of includes. for Microsoft, I need this no min max, and the header that I'm about to include here needs string and IO stream. I need to clean it up and make sure that this is in that header. But for now, just add these few lines, this define no min max, include string and include IO stream. Then after A3D SDK includes, just include Exchange Toolkit. So this should be in the include folder of your Exchange directory if you downloaded the zip file that Jonathan previously provided. If it's not, if you don't have that, or if you have a previous installation, go to the chat window and grab the second Dropbox link that Jonathan provided. And that'll just be this header, and drop that in your include folder, and then you can catch up. So I'm gonna eliminate that code that we wrote there. This should go in undefined. But what you'll find is everything in that header is in the Ts3d namespace. And immediately you can see we have wrappers for every single data type that there is in Exchange. We went through and made sure that every single one is covered. So you should never have a problem declaring the A3D ASM model file wrapper. So it's named slightly different. I dropped the word data just to keep it a little bit more concise. So now this object will basically behave the same way. And we can come back to this code, uncomment that. And instead of using model file data, I'm just going to use d arrow. And same thing here, d arrow. Oops. So let me set a breakpoint here and run this. It's loading the CATIA file, and it broke. So I'm going to step in just so you can see what's going on here. I think it is always helpful to understand the mechanics. So we're looking at Exchange Toolkit.h right now. And this is a macro that is declared for every data type. And the macro expands to the code that's just above. And it looks a whole lot like the code that I provided, that we wrote together. It's just a little bit more complicated because there's some macro expansion stuff in here, some concatenation of strings, things like that. But overall, it's the same idea. We initialize, we get, we release. There's arrow operators overloaded. There's also a .reset function. So if you want to reset it to a different pointer, you can do that. Sometimes that's a useful thing. And if we scroll down in the header, we can see that this is declared for virtually, well, it is every type of data object in Exchange. So that should save you some time. It'll also save you lines of code. We went from 4 lines of code down to 1. So this is super helpful. I think if nothing else, this is a tool that you could use immediately with, in my opinion, well, very little risk. So you brought up the point of the checking of the result code. And actually just looking at that implementation, I thought I had in there the mechanism that I will share in a bit for checking results, but this header is actually an earlier iteration of ongoing work that does include the result checking. But I'll show you a tool that I have just for general result checking and some utilities around that in just a moment. So let's see, let me make sure that, okay. So any questions so far?
Looks like Elvis may be having a problem compiling once hitting the Exchange, once including the Exchange toolkit. And then also, I apologize, it looks like if people are joining us late, those links in the chat may not be there. So I just submitted those as well, the new links, so that everyone has those. And maybe Robert, if you don't mind giving Elvis a hand with the compile errors, we'll try to sort that out for you.
Yeah, go ahead. I'll work with Elvis.
So sorry, just to make sure, I think I've seen errors before. The first step, just make sure that you have these 3 lines in your code first before you do anything. Define nomin max, include string, and include IO string.
Yeah, it looks like he's getting a legal token right side of the double
I'll
colon.
bet that token is STD.
Yeah, it worked. Sorry.
Yep. Okay, great.
I missed one letter for nomin max. Thanks.
That happens. Yeah,
Yeah,
no
thanks.
problem.
Cool.
Okay, so let me move on here. So let's talk about the result checking. So I'm not gonna use the wrapper here. I'll do a direct implementation. So one other object / macro that is in this header is a function called check result. So we can do this. So let's do it the old style way. So I'll say A3D ASM product occurrence data, and we'll call it POD, and we will initialize it. I know my hotkeys for moving the cursor around are going to move my desktop, so I don't want to do that. So I have to do it with my mouse, which I hate doing. Okay, so this check result macro, I'm going to use to wrap my call to A3D ASM product occurrence get. And what this is doing is, this basically returns a Boolean instead of A3D status, which makes things easier. So it's either true or false. So if this is true, then I know that that API succeeded. If it's false, I know something went wrong. What went wrong? Well, if it went wrong, if not check result, then I can actually use Ts3d check result. This is a singleton. And I can get all the information about the failure. So I can get the last result so I can inspect it more closely. I can get the file, the function name, and the line number that the failure occurred on. I can also set on this object, this singleton object, I can set a failure callback. The default implementation just prints to standard error what the failure was and where it occurred. So in order to illustrate that, let me comment out this line. And since we didn't initialize the struct, this function get should fail with an error. So we can look at what that behavior is. So I stop the code and rebuild and run. Should hit a breakpoint, and then I'll just step through. So I declared data, but I didn't initialize it. So when I call get on it, it's going to fail. And that failure produced the default behavior of the API checker, which is just to say API failure, A3D ASM product occurrence get, it failed with an invalid data struct size. That's exactly what I would expect for this error. So this could be used to more easily, so this saves lines of code because I don't have to write A3D_success all the time. It's just a Boolean. I can implement that failure to throw an error. So if I wanted to, I could say Ts3d check result instance dot set failure callback. Now this is a function object that takes the A3D status, sorry, the checker as this takes the object and I can override the return value. So if I return true here, so for example, let's say that there are some results that are okay for me, like if the result is equal to, I don't know, there are some APIs that they don't return success, but it's an error code. That means that things are still okay. Let's like continue on error or something like that. I can check for that result and I can return true. And when I use this macro down below, it will return true. So I can just basically customize the behavior of the check result macro just to be sensitive to non-failure but non-success result codes. The other thing that I can do is throw an error here. So if there is a failure, I can throw a standard runtime error or something like that. So this would allow me to set the default behavior of any use of check result. So to answer the earliest question that we had of the wrapper and the getter not checking the result code, the implementation in an upcoming revision will use this check result. And with it, you could customize the failure callback to throw an exception if you wanted to. So that would mean that this constructor would throw on failure, which is unusual. It should not. I mean, the only reason it would occur, I suppose, is if you're passing in the wrong data type. So it's an odd situation for that error to occur, but it certainly could. And this is one way that you could handle it. So I would say take that information and do a little bit more research and reading in the Exchange Toolkit, and you can see how you'll be able to use that within your implementation. And again, I think that that will save a few lines of code and make things a little bit more easy and readable. Okay, so we're moving along here. We have some, again, it's a very simple code. We've written a loop here. This is a pretty typical thing where you have an object that is a container and it has children and you want to get to those children. A lot of times you wind up writing this loop. That's a classic C-style loop that's iterating over an index, and then you're accessing this index to get the pointer out. So another way that you can do that is if you're familiar with standard make pair or standard make share, these are ways that you can get pairs and objects with type deduction. So I've added to the toolkit a similar function called toVector. And this is a way that I can pass in an opaque pointer or a pointer of any type and the size, and I can get back a standard vector of those objects. Now this copies that memory. So, but remember, these are opaque pointers, they're void stars. So the amount of data that I'm copying here is pretty minimal. So I can say autoconst product occurrences equals Ts3d toVector, and I'm passing in the product occurrences and the size. And now I can write autoconst POS. So I can do all the same work inside the loop, which is a little bit more concise. That's nice. We can also change this to use the wrapper. And you can see how this code just starts to shrink to nothing. I just reduced all those lines of code. Saves time and saves bugs. You know, the more code that you write, the more likely you are to create bugs. So this is a nice tool as well, this toVector. What this requires, though, is the knowledge that within a model file that you have, you know that you have product occurrences. Another way that we can do this is within Ts3d, we have a function called getChildren. This also requires that I declare a model file wrapper and I call get on it, and I have access to the struct. So in some cases, you just have this opaque pointer and you don't want to necessarily go through the trouble of getting the data out. Even through a wrapper, this line of code, it's an extra line of code. So we have a method called getChildren where I can just pass in the opaque pointer, and I can pass in the type of object. What is it? K3D I'm trying to remember. Type ASM product occurrence. So with this, basically it does the same thing where internally, it's going to take the product occurrences from the model. It'll get the model file data. It'll iterate. It'll find the product occurrences and return them as a vector. So this is a standard vector of product occurrence stars, And remember, product occurrence stars are void stars. So this is what another object that's present for you is a type def of an entity array. So this is a standard vector of void star. And let's see if we just do this peek. We can see using entity arrays standard vector of the void star, A3D entity star. So this is also type def to void. So entity array is a very general container that you can use for an ordered collection of opaque pointers, whatever type they are. Entity set is a standard set. Sometimes the order doesn't matter and you just want a unique set. So this is also very useful. Entity array, entity set. These are all in the Exchange Toolkit ready for your use. I'm going to pause. I'm moving along here pretty quick. Let me just take a quick look at the chat. Cool, got the links, participants. So how about thumbs up, thumbs down, go faster? Any questions up till this point? I really appreciate your participation. The feedback is really crucial to help me gauge your engagement and understand if I'm going too fast or too slow. Good speed. Thumbs up tells me things are going good for you. If you can tell me to go slower or go faster, I'd be happy to adjust. Again, thank you for the feedback. I do appreciate it. It's hard. These are trying times, as they say. This COVID makes it hard to engage, but we're doing our best. Okay.
One question for you,
go ahead.
Brad.
Yes.
Can we use Ts3d, I'm guessing the Ts3d wrapper that Brad is showing you in a productive way, like I imagine in production?
I would say absolutely. And the reason is just due to simplicity. I showed you the implementation of these things. It is about as simple as it can get. I think a lot of people wind up implementing this stuff themselves, which takes time and may be error prone. So my suggestion would be, use it. Because it makes life a little bit easier. And we anticipate that some of this stuff will make it into the product, so be officially supported at some point. But for now, it's all available in the labs.techsoft3d.com. We have a Git repo, and the full project with all the documentation is available there. I'll show you that to you in a second. But I would say, yeah, go ahead and use it. I don't see any reason not to. All right, so we're just writing code for the sake of writing code here. It doesn't seem like we're actually doing anything useful other than just illustrating some concepts. So one common workflow that we see is the need to get all parts. So to traverse the product structure, get down to part definitions so you can perhaps extract tessellation or extract the brep data. So I'm just going to write some code now that shows how to do that with the concept of the model file wrapper, or all these wrappers actually, not just the model file wrappers. So let me dump this code out. I don't think we need to export anything. So for each product occurrence, we're going to call a function to traverse the product occurrence. So we want to look at each product occurrence and we want to see whether or not it has a part definition. So let's create this function, traverse product occurrence. I'm going to go to the top of the file. And I'm going to start just by calling it a void function. We're going to update this in a second. So here now we have a product occurrence and we want to find out, does this product occurrence have a part definition? And does it have child product occurrence? Remember, product occurrence is like a node in the assembly tree. So does it have child nodes? Does it have children? Or does it have a part? Or maybe both? So if you know anything about Exchange, you may know that there is a concept of a prototype. Now, prototype is a way that we accomplish part sharing. So if you have a shared part that's used multiple times in a CAD file, that will appear through the concept of a prototype. So if I look here, m_p prototype is actually another pointer to a product occurrence. So there's this kind of recursive nature of product occurrences. This is how we accomplish part sharing. The other thing I can have is a part, and m_p part is a part definition. So does it have a part? We can look at m_p part. Is this thing null or not? Well, that actually doesn't tell the whole story. We need to know if the product occurrence does not have a part. We also need to look at the prototype, because this may be an instance of a product occurrence that actually has a part. So in order to get the part definition, we ultimately need to write another function to find the part definition given a product occurrence. So what does that look like? So let's say A3D ASM part definition, find part definition. Not quite. So this function, let's say if it's null, we just want to return null. Otherwise, let me steal this line of code. We want to return product occurrence data, m_p part. If it's not null, we want to return that. Oops. Otherwise, we want to find part definition of POD's arrow m_p prototype. So this function now is written, so give me a product occurrence, and if it has a part, I'll return you to the part. And if it does not have a part, then I will look at the prototype and see if it has a part, and so on and so forth. This is a recursive function that will recurse through the prototype chain and give you a part definition associated with a product occurrence. So we can use that now. We can say auto part equals find part definition. And if it has a part definition, now we can do something with the part definition. And I'll fill this in a second. The other thing that we need to do is iterate over the children. So if the product occurrence has child nodes, has children in it, then we need to traverse those as well. So I can say for auto child PO in Ts3d 2-vector, I need this up here. So in this case, we're going to traverse product occurrence to child PO. So we generally have written here now a couple of functions. They're not really returning any data, but the overall structure is here. Where given a model file, we can traverse over its product occurrences and then traverse recursively into the product structure, basically looking for part definition. So now the question is, well, what do we do with this? So essentially, we want to return a collection of entity pointers that will uniquely identify each part definition in the product structure. So I'll write a little bit more code, and I think that will become clear what we're up to here. So let me scroll back down here to the use of this. And I'm going to declare a Ts3d entity array. Remember, this is just a standard vector of entity pointers. Arbitrary type, doesn't matter what type they are. And we will call this instances. Well, sorry, let me take that back here for a second. So we need, yeah, that's right. Just to keep things consistent, I have some notes here. I just want to keep things consistent. So we're going to call this owners. So these are the owner entities of the part definition. So the first owner is the model file. So we're going to just push back the model file into this list. And let's pass that into this traverse. So we want to pass in a standard vector of entity pointers, or the entity array, into the traverse product occurrence. So let me add that as a pass parameter here. And we're going to do that by value. And the reason is we want to basically take a copy of this and add the current product occurrence to the list of owners. And we're going to pass that current owners into the recursive call, just to ensure that we're appending to this. So like this, current owners dot pushback part. So now we basically are passing around a vector of opaque pointers. And when all is said and done, what we really want out of this is the collection of those opaque pointers, so we can uniquely identify each part definition in the product structure. So this is getting a little bit more complicated, but through the use of this type deaths, the code isn't terribly intimidating. So here we want to return a standard vector of entity array, because there may be there will be multiple instances, and we want to capture all of them. So we have a vector of the entity array. So let me declare this as a result type. So we want to return the result. Okay. Let's see. In here, we want to add current owners to the result and then return the result. So this is our terminal state for this recursive call. And here we have from the recursion, we should have for any child nodes, we should have any child part instances here. And what do we need to do with these? We need to append them to the result. And if you're a C++ kind of guy, you know that this is a call to insert in order to append one vector to another. Part instances dot begin, part instances dot end. So this appends any results from the recursive traverse into the product occurrences onto the result, and this returns it. So we wrote a bunch of code here. It's relatively concise. So I'm going to guess that many people here who have used Exchange have probably written code that achieves the same goal here. And again, that goal is to traverse the entire product structure and find the unique path to every part definition. So that's a recursive function. It involves the use of the product occurrence prototypes. It also involves just maintaining this list of entity pointers and keeping things in track. So let's test this. Let's scroll down to this use of the code, and we'll say part definition instances is this. And we'll just say, we'll just write out, there are part def instances dot size part instances. in its, okay. So is everyone tracking here? I know I upped the pace here. So let me just jump to the participant list and we'll do a quick check-in again, if you don't mind. If anyone would like, if overwhelming majority of you would like additional explanation, I'd be happy to do that. Okay, we're getting a slowdown. I'm cool with that. I can do that. Any other feedback, please? I would love to see it. It's really helpful to me. I'm getting a lot of thumbs up. I'm happy to see that. I don't mind seeing slowdowns. I will do that. And I'm going to show the result here and I'll explain exactly what happened. I think when you see this, it will become very clear. All right, I'm getting a good feel. Okay. All right, very good. Thanks. I appreciate that. So let me run this. And we'll look at the result. If everything went well, we'll be looking at the result. It usually takes me a time or two to get it right. So we have an entity array of owners, and I'm pushing the model file onto that list. Now I'm iterating over each product occurrence, and I'm recursing into the list of product occurrences to find unique part definitions. And with every part definition that we encounter, we're essentially returning a list of all the product occurrences that it took to get there. So when all is said and done, part definition, this part def instances, this is a collection of arrays, and in each array is a collection of opaque pointers. It starts at the model file, includes every product occurrence, and ends with a part definition. These are all opaque pointers. So remember, you have to use the A3D ASM model file get and the data to actually read data. But these are all just the handles. This is all that you really need. And I got 21 of them. And that should be written to standard out. That's beautiful. Remember, I like the micro engine. Let me fire up the HOOPS demo viewer. And we will load that micro engine. Just so happens to be in my recent files list. It's beautiful. I love this. So let's count them. So we have the housing. Here's one part, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 21. So we are right where we need to be. We have basically in that vector, we have, so if you look at the model file, the product occurrence down to the part definition, we have this structure essentially now in our arrays. So that was a lot of work. It's a common workflow though. So what do we have to help you with that? It's at this point that I will introduce you to some of the tools that help you with this type of traversal. There's a function within the toolkit that's in your header file called get instances, get leaf instances. That's the one. And with this, I can pass in the opaque pointer of the model file. And I know that I want A3D type, what is it? It's type part definition, right? Sorry, I always get this wrong. ASM part definition. What is this returning to me? An instance path array. So what is an instance path array? Let's look that up. Peek. Isn't that nice? So it is a standard vector of instance paths. What is an instance path? An instance path is just another word for an entity array. So when I say instance path, I mean a very specific thing. This is an entity array. An entity array is arbitrary. You can put whatever you want in there. But when it's an instance path, that's very specific. It means a model file followed by a product occurrence, followed by n number of product occurrences. down into the product structure. So it's very specific about the structure of Exchange. An instance path uniquely identifies a specific instance of a part within the model file. So that's why we use the word instance path instead. Just helps to clarify. So the result type here is a standard vector of instance paths. So it's essentially the same data type. And part instances here should be the same count. Let's just take a quick look. So you can take all that code that we just wrote and all the complication. I know it was a little difficult to follow. I had to refer to my notes a bunch of times. I had to write it beforehand just to make sure I got it all right. Oops, my bad. I accidentally hit space. 21, thank goodness it worked. Thank goodness. Okay, so there's a tool that you can use to get all of the unique instances of any given type. So I don't care if it's a part definition or if it's a representation item of a particular type or really anything in the product structure. You can start with an arbitrary owning type, whether it's a model file or a brep body or anywhere in the structure, and any child type. And this code knows Exchange. It knows how to traverse through the data structures and extract what you're asking for, and it will give it to you. This saves a ton of time, and it saves a ton of code that's potentially error prone. So I would love to step into this code because I get really excited about how it's implemented, but I'll leave that to you. Essentially, it boils down to a map of lookups. And it just knows each type, what is the owning type and what is the child type you're asking for and how do I get to it? And it builds a path, figures out how to traverse the product structure and just returns that result to you. So this is useful. This is get leaf instances. So I'll show you a couple of variations of this now. So what happens if you don't really care about how you get to the part? You just want a list of all the unique parts. So for this example, this screw is shared. This backface screw, there's 4 of these guys. They're instanced. That screw exists once, but it's instanced 4 times. Same with the screw on the head here. This is a shared part. It occurs 4 times. So there are a bunch of other parts here that occur only once. But imagine you're writing some code to process every unique body. You want to extract tessellation. You want to extract the brep data. You want to perform some analysis on each individual part, regardless of where it exists in space. You just want each unique part. Well, we got a function for that too. That's Ts3d get unique leaf entities. And this, I can pass in, same deal. Let me just copy and paste. Well, so this, I can say auto const unique parts. So this does not include any part sharing. It does not include any instance paths either, because I don't care how I got to this. I just want every unique part. So the return type you can see is an entity set. Remember how I said that is sometimes a useful thing. So in this case, we should have fewer than 21. It's going to be 21 minus 8 plus 2. Should be what it is. So let's see how many we got here. How many unique parts are there? Right? It should be 21 minus 8 plus 2. Because there's one, I think that's what the answer should be. This seems like something I should have done beforehand. Let's see if we're in the ballpark. 15.
Hey, Brad.
Right. Yeah.
We have a couple questions that might be a nice.
All right. It's a good, yeah, it's a good point to stop. This is a very good point to take some questions. So if you want to unmute and ask them, or if you just want to relay them to me, I'd be happy to take them.
I think there's 2 from Jens. So first, when it comes to prototypes versus external parts versus parts, they're confusing. you always recurse everything, or are there times when one indicates that the others shouldn't be traversed?
That is a good question. Honestly, I'm not very familiar with external parts, so I'm not going to speak about that. One of the other CEs on the channel on this call would be happy to take that answer if you're ready with it and you know it. Otherwise, I can get back to you on that and answer it. But with respect to prototypes and parts, so generally, when you look at a product occurrence and you want to find its name, for example, or you want to find its part definition, if it is null, your job is not done. You need to look at the prototype. If the prototype is not null, you need to examine it and look for its name, look for its location, look for its part definition. And that in turn is recursive. So the prototype may not have a part definition, but it may have its own prototype pointer. So you need to examine that. And that's why I wrote this function as recursive. And does anyone else from TechSoft want to comment on the external data? I'll just pause a second. Okay, we'll have to get back to you on that one. I don't have a lot of experience dealing with the external data links. So sorry about that. Next question, attributes, cascaded attributes. This is great. This is a very, very good question. Let me just answer that very quickly. So one of the things that we're very well set up to do now that we have a vector of entity pointers, we're very well set up to deal with cascaded attributes. So first, a quick note on what is a cascaded attribute. So if you have a part and you want to determine, for example, if it's shown or not, is it hidden or is it shown? The part alone does not tell you that. The assembly structure that leads to the particular instance of a part can control the part visibility. It can override whether it's shown or not. It can override its color. It can override a number of different attributes that the part must inherit. We accomplish that inheritance through a notion we call cascaded attributes. In order to use cascaded attributes, you need to declare an object, passing in the model file pointer, declare another object, passing in the product occurrence pointer, and so on and so forth down the line to the actual part definition, at which point you can combine all this data and compute the final net visibility or the net color. So that's the mechanism of cascaded attributes. So in the toolkit, this is getting a little bit more advanced, but it's there. We have an object called a Ts3d Instance. And what does this take for a constructor is an entity path. So let's just take part instances at 0. We know that this is a valid part. It's the first one on the list. So I just grabbed the first part instance, and I'm saying part instance because it has an instance path. It has a complete path from the model file down to the part definition, all captured in that standard vector of opaque pointers. And I'm constructing this instance object from it. Let's take a quick look, peek definition, at the instance object. Again, in the Exchange Toolkit header, take a look for yourself. And let me just point out, this is all in the GitHub. So that means that you can clone this, you can modify it, you can push changes to it. If you find bugs I put in here or there are improvements, whatever you want to do, this is an area that we would welcome any feedback. So anything that you have to offer, we're happy to help. So an instance does a number of things. It just has some helpers on it, like get name. The leaf is actually the final entity pointer in the path. So you'll see the use of this function leaf, and you'll see you can get the path. This is just an instance path. You can get the type. You can get the owner. So this will basically pop off the last object in that path and give you a new instance. That's the owner. This is very useful. There's a reset. Oh, look at that. we have some cascaded attribute data in here. And that is used through these, what I call the net attribute getters. So I can say get net removed, and that will compute the cascaded attributes given the instance path and let you know whether it's been removed, whether it's shown, what is the net style, what is the net layer. So with this information, then you can go on to obtain the style data from the global structs. So this is how you can handle cascaded attributes within the context of using this toolkit. If you want to roll your own, you can do that as well. You can just see how this implementation here, how it actually it creates the cascaded attributes and just holds that as a member variable just for future use within the context of the instance of the class. But that's one way that you can deal with cascaded attributes. I hope that you find that useful as well. So this is the instance class. It really exists just to help you with cascaded attributes and some common functions like finding a parent, things like that. Let's see, I'm just gonna take a quick peek at the chat, see what other questions we got. Oh, we got a bunch rolling in, that's great. Programmers returning -1. Yeah, so, Paul, it sounds like you missed a step. I would back up to a clean install and run from, make sure that you're able to run without any modifications in it. We're recording this session, so I think you're gonna have to play some catch up with the recorded session. Is it possible to get how many instances there are for each unique part? Ah, love that question. Okay, so let me jump back to the code here. And we have this get unique leaf entities. And this just gives me a set of unique parts. Well, there's another variation of this. It's overloaded where I can declare an instance path map. And I can call, let me just steal this code. I can call the same function and I can pass in an instance path map. So let me just, what do we have here? What are we doing? So we're asking for all the unique parts and we get them as a standard set. But in addition, I'm passing in an instance path map. This is passed in by reference. So the function fills it out and returns it to me. This is actually an out, it's a return value. What is an instance path map, you might ask? Let me peek the definition of this, and you'll see that it's a standard unordered map with a key of an A3D entity type and an instance path array. So hopefully your gears are turning. What does that mean? So that means now that I can say for auto unique part in unique parts instance path map at unique part. What is this? Auto, what would you call it? I would call it auto const instance paths. Let's be a little more explicit, to this part. So what are the instance paths to this unique part? This should be an instance path array. It's so from here now we have, let's say standard count. There are instance paths to this part dot size instances of this part. So this is an easy way to make a bill of materials. That's basically what this code has done. I don't know how many of you have ever written the Exchange code to come up with a bill of materials, but here we did it in 6 lines of code, 2 or 6 lines of code. We create an instance path map. We get all of the unique leaf entities with the paths to those unique entities. So we have a standard set of unique parts, and then we have a map to look up what are the instance paths to get to those unique parts. And now for kicks, let's just run it just to make sure that I'm not crazy. Well, you know what I mean. And I'm mindful of my time. So we're at 10 minutes after. I hope you're all enjoying your coffee if you're on the West Coast. If you're in Europe, I hope you're enjoying a glass of wine or whatever it is. So, so for each of these, let's just run through. We should see, yeah, so there's one instance of a bunch of parts in there, but then there's these fours, those are the screws. So that's exactly what we would expect. So that's how you can do it. Just a variation of this get unique leaf entities. Super, super helpful. And again, from these part definitions, I'm running out of time. My inclination was to start to show you how you can use this to traverse the topology as well. So if you have a brep body and you want to find all the unique faces, you can use this exact same code. If you want to find all the unique edges, you can do the same thing. Just pass in the brep body and ask for the edge type, and you'll get back all the unique instances of edges. And the instance path map would include everything from whatever the owner is that you passed in all the way down to that leaf node type. All right, let me just catch up on questions. Two-part question. So I'm reading Jacob Arnold's question to everyone. Consider that we want to load the same model multiple times across time, maybe different HOOPS versions. Is there a way to uniquely identify each node? Say that I have something externally for each part. Load the model again, look it up. So this is where it's a little complicated. So generally speaking, some CAD file formats have a persistent ID, but then there's also non-persistent ID. So there will always be a non-persistent ID and there will sometimes be a persistent ID. This is associated with the root-based data, if I'm not mistaken. So there's a loose concept of inheritance within Exchange. Everything is derived, and I'll use that in quotes, from the root-based data. Root-based data includes these IDs. I believe that is your best bet to try to track things across sessions, would be to look at those IDs and use that as a mapping. If you have the ability to load a file and persist it as a PRC, that would be a better option in my opinion, because PRC is going to save and load much faster than the original file format. And you can associate arbitrary attributes with objects. So you could create your own identifier as a string perhaps, and attach that as an attribute to the thing that you want to track. And then you can come back later and look for those attributes. That would probably be the most reliable way to do it, and the fastest way to do it as well. Oh, good. Yeah, for some models, persistent ID, non-persistent ID seems empty. What could cause this? So some file formats do not support the concept of a persistent ID. The non-persistent ID, I believe, is generated by Exchange. So I'm not sure why that would be empty. I think maybe if we could, let's note that as an open question that we'll have to follow up on. Anything else? Okay, very good. So let me just see where we're at on the grand scheme of things here. So just a couple other helpers before we run out of time here. Maybe I'll do this through the documentation instead, because it may be more concise. So let me bring up my browser. I'll move it over to that window in a second. Okay, we'll wrap things up. If there are any questions, feel free to jump in. But this is the wind down. So this is about it. So how do you get to the toolkit? Aside from the links that we sent you in this chat, you want to go to labs.texsoft3d.com and you'll find what we're calling the Exchange Toolkit. I'm going to throw it out there. This name just kind of happened. If you can think of a better name for this, we'd love to hear it. We're still trying to refine what we should call this set of functions and how we should package it. You know, this is why we call it Labs, because it's open to discussion, open to your input. The Git repo can be found here. So click on this. This will take us to GitHub. This is where you'll find all the source. You'll find a bunch of examples. So these are very useful examples. Attrib shows basically how to get attributes. BOM shows how to build a bill of materials, so on and so forth. Here's how to write an OBJ file. So this shows another tool that's in the Exchange Toolkit, which is an easy way to get out an indexed triangulated mesh. If any of you have dealt with the tessellation within Exchange, you know that it can take a number of different forms. I think there's a total of 12 different variations that you need to account for in your code to get ultimately to get triangles out. The Exchange Toolkit provides a helper to get just an index list of triangles. So this sample shows how that's used. There's a bunch of samples here that, I don't know about you, but I learned very well from sample code. So I felt it was very important to provide as many samples as we could. The include folder has the Exchange Toolkit. Here's Eigenbridge. Actually, I didn't even mention this. So maybe you're familiar with Eigen. This is an open source linear algebra toolkit, very useful in my opinion, very well documented, easy to understand, easy to use, and performant. So rather than write your own, or for even us to write our own, we have this Eigenbridge. This will take, for example, a vector 3D from Exchange, or a generalized matrix transform from Exchange, and it'll create an eigen object and give it to you. So this allows you to very quickly and easily compute matrices. And you can see that there's functions for getting the matrix or getting the net matrix of an instance. So it recursively goes through the owners, computes matrices, combines them together, and gives you that final net matrix. So if you have an instance down to a part definition, if you have an instance path down to a part definition, you could use a function like this to get its global orientation just by calling get net matrix on an instance object. So more useful tools. Let me jump back. And just very quickly, we're going to go to the API reference. So the header, as I'm sure you can tell if you've looked at it already, is documented using Doxygen. And this is the result of that documentation. There's a description of a lot of what we just talked about. So Traversal, this talks about instance paths, the recursive nature of product occurrences. Talks about what is an instance path. These are the type defs that we all talked about. Get leaf instances, so on and so forth. It shows a bunch of sample code and bill of materials. So this is the code that we just wrote together. And it just so happens to be the micro engine. Go figure. Data access. Same thing, wrapper macros. So we just developed this together, but here it is concisely stated. And of course, the API reference. So data access wrappers. Here's all the different wrappers for all the different data types. Here's instance. Well, we didn't talk much about the tessellation, but here's some objects to help with tessellation. Some type defs for entity array, entity set, instance pointers. Sometimes, shared pointer to an instance can be useful. The helper functions to vector, is representation item, is test based. So these are used because, again, this loose inheritance that is within Exchange. These are actually used in the internal algorithms, but they can be useful externally as well. How many times have you written the 4 lines of code or 3 lines of, no, I'm sorry, I'm exaggerating, 2 lines of code to get the entity type? Using Exchange directly, you have to declare the enum, then you have to call get entity type, and it's passed by reference. So it's 2 lines of code. It can be reduced to 1. Just use Ts3d get entity type. Little things like that just make life a little bit easier. Yeah, and I think that's it. So let's look at the API reference for Traversal. We went over almost all of these functions: the get children, get leaf instances, get leaf entities, and here's get owning instance. So if you have an instance path and you want the owner of a particular type, this will traverse up the product or the instance path until it finds that type, and it'll return to you a new instance path. So for example, if you have a full instance path down to a face, but you want to know what body owns it, you'd use this function, get owning instance of the body type, and it will just traverse back and give you the subset of the instance path up to the body. So there's a bunch here. There's a lot of stuff that we covered. There are a lot of things that we covered most of it. So there are a few things that we did not cover. But I think that in bulk, you've gotten a lot of the core concepts, a lot of the fundamentals and the knowledge. And hopefully what you're taking away from this is that with the addition of a single header into your Exchange folder, you can save a lot of code, and I believe a lot of headaches. This code is also tested. There's a test suite that runs thousands of tests on it. It's just a lot of mechanics of loading files and comparing numbers and using raw APIs compared to the Exchange, these wrappers. So I'm quite confident that you won't encounter any bugs in the actual implementation. And again, the beauty of it is you have the header. It's all implemented in the header. It's all very straightforward. You can augment it. You can improve it. Anything that you do, we want to hear from you. If you have suggestions or for improvements or corrections, please, please, please feed that back. We can make this kind of a community project and improve things together. So I'm coming up on my hour and a half. So I'm going to stop. And maybe if you want to open up your mics, give me any feedback, any questions, anything that you'd like to bounce off of us. We're happy to hear it. Hopefully I've answered many questions, maybe not all of them. I think I have some catch up to do. I'll stop talking now.
There is one that came in about parsing feature trees, which is a relatively new set of features in HOOPS Exchange. Is that something that you've been able to wrap? Because that can get quite complicated.
Yeah, so there is one caveat with the feature trees. The feature trees, largely all the code there is included, and we can traverse them. The code that does that traversal, that magic inside of get leaf entities or whichever function you're using for traversal, it relies heavily on the type of the object. So the get entity type needs to return a valid enumeration, that type. There is a class, I'm not remembering off the top of my head which one it is, but there is a class inside the feature tree hierarchy that does not return the correct type. And for that reason, it's a little complicated to actually traverse the feature trees with this code because it can't get past that point. So I'd have to, I know I filed a bug on that. I'd have to look back at which one that is, but I think pretty quickly, if you try to use this code with it and you start stepping through, you'll see what works and what doesn't. But there is a case that does not work. That is the one issue I found with feature trees. Otherwise, it does work. It is a pain. I would agree. It is very complicated. Any other questions? Anyone want to provide me any? I see a thumbs up. Any feedback? I appreciate it.
Well, thanks, Elvis, for your kudos there, and thanks, Brad, for taking this on. This was fantastic. This is part of a greater set of training sessions that we're going to be hosting here at TechSoft. We have a few more coming up between now and the end of the year. Next week, we're going to be talking about building operators in HOOPS Communicator. So that's kind of exploring the existing operators for data navigation. Following that, and then also part of that is building your own custom operators for data navigation and interrogation. HOOPS Communicator is our web-based API for visualizing engineering data in a web browser. Following that, we have one, again, based on HOOPS Communicator, building a product configurator, so kind of a more advanced workflow on how to bring in different types of data and be able to visualize that in a web context. And then lastly, the beginning of November, or no, kind of like mid-November, or December, I think it might actually be December, we have building applications using HOOPS Visualize and HOOPS Exchange on Android if mobile development is something that interests you. We do encourage you, if you don't have a full evaluation of HOOPS Exchange, the one that you downloaded today or this week to use in this this training, that license file is good for the next 10 days, so till the end of October. If you want to continue experimenting with the Exchange Toolkit that Brad has shown you, as well as HOOPS Exchange to read CAD files in your technology stack, We can give you a full 60-day evaluation if you go to techsoft3d.com and sign up for that. And you'll be paired with one of our consulting engineers like Brad to customize that and work through your specific workflows, make sure that you're getting the most out of our SDKs. So that is an option. We encourage you to go and do that when you're ready. But again, Brad, this was fantastic. Thank you so much for taking the time to do this. Everybody, we know your time is valuable. We really appreciate all of your questions and your participation in this training today. We hope to see you in the virtual space or in the physical space sometime in the future, because we do really enjoy working with all of our partners to see what you're doing, what exciting things you're doing, driving innovation here in 3D engineering.
Yeah, thank you all for taking the time. I very much appreciate it. I hope that you got some value out of this, and look forward for any feedback that you might have to offer.